our next speaker, Zack Jackson, will be talking about Webpack 5 module federation. Zack is a principal engineer at Lululemon, I think I said it correctly, core maintainer of Webpack and creator of module federation. In his talk, he will focus on Webpack 5 module federation feature that allows microservices and micro-frontends to work as seamlessly as a monolithic application would. Say hello to Jack. Hello, Jack. Zack, sorry.
Hello.
How are you?
I'm doing all right. How are you doing?
I'm great. Zack, so the stage is yours. Have fun.
All right. So let's get started. Let me share my screen here. Okay. Can everybody see it? Looks like it's sharing. Okay, cool. So let's get into it. All right. So module federations, distributed application architecture, independently deployed bundles that work together as a monolith at runtime. So the general issue that we've seen with micro frontends or any kind of distributed JavaScript system is that the scalable solutions are quite challenging. The closest thing we kind of had was either to use externals or DLL plugin, but it was always a hassle to share code or do progressive updates to underlying vendor code or anything like that. And at scale, it was more or less unfeasible, unproductive, or just unprofitable. So let's set some context here. You want to be able to deploy a multiple application stack or parts of an application independently. You want to try and avoid downloading multiple copies of dependencies when you load other applications or bundles. And you don't want to have to run into a double deploy scenario. So double deploy is kind of like if you abstract stuff into an NPM package, then you have to, you'd have to end up, pushing and publishing the package, then go to whatever repo you're consuming it in, bump the version, and then redeploy it. So you're always stuck in this double deploy scenario. You might want to remove reloads when you move between single page apps or micro frontends, and perhaps you want evergreen code or the ability to share certain pieces of code or anything like that. So the problem statement. Oh, this image cut off my my animation underneath. Okay, so what's wrong with the current solutions? Most of them are brittle. They're hard to roll out. There's usually a lot of code duplication. Comes with a lot of engineering and maintenance overhead. That usually is kind of in-house based. Evergreen code is quite difficult to actually achieve, and most of it requires some form of manual labor. If you try to get into SSR, it's even worse. So the terminology that I'm going to set out here that I'm pretty much going to use throughout this presentation. First, there's the module federation, and it's kind of on the similar idea of Apollo's GraphQL federation, but it's applied to JavaScript modules. And the other big thing is it doesn't really depend on like a network API call per se, but the similar aspects of how Apollo brings together multiple graphs is kind of similar to what module federation does. We have something called a host, which is essentially just a Webpack build that is first initialized on the page load. You have something called a remote, and that's another Webpack build where part of that is being consumed by the host. Then we have a concept called bidirectional hosts, and this is where a bundle can act as either a host or remote, either consuming applications or being consumed itself at runtime. So what exactly is module federation? It's the ability to import code from another single page app or another bundle at runtime. You're able to share vendor code dynamically at runtime. You can deploy independent SPAs without needing to redeploy the consumers. And it's got some level of redundancy and self-healing capabilities. Micro frontends are microservices that work like a monolith, and the developer experience is improved without compromising the user experience. You have the ability to have evergreen code directly from So if this font's okay, sure. If not, just let me know and I'll increase it some more. So yeah, pretty much, I've got my public path set. I've got the module federation plugin added on here, which is accepting a remote and exposing something to be consumed by other hosts. And yeah, I use suspense. I have a little fallback here. What you could also do is have a fallback be a stale version that you install over npm if you're looking for that level of redundancy. So it's evergreen if possible, otherwise falls back to the last deployed version that you have. It's a little bit more work, but if you're looking for that additional stability, it's a pretty solid solution to it. So I'm going to jump back into the project here. And now we've seen localhost 3001. You'll notice that I pull in remote entry from 3002, the main bundle from 3001, and then I'm pulling in 3002's button of 2.3 kilobytes. Now I'm going to go over here to port 3002, and you'll see the same thing. app2 works, and I have the original button from app2, and I have the button that I loaded from app1. And you can see the complete reverse here where it's now from 3001, and the remote entry pulls in from 3001 as well. So that kind of shows a really simple example. If I didn't use module federation, you wouldn't see the red button on here, and on the other app, you wouldn't see the blue button on here. So that kind of gives you a really basic example of bidirectional hosts. I'll get into more real world examples later on in this presentation. So that's really a simple way to implement it. As you saw, I really didn't do a whole lot. I put a plugin on and I used pretty much just a standard import and it was done. So it took less than maybe 5 minutes to actually set it up from more or less scratch. There's nothing really you have to change. Your development workflow doesn't have to change. You don't need to handle some kind of third party or script loading. It's just standard require or standard import. So server-side rendering is also really cool because we can apply the client-side aspects that we just showed off to a server-side render. So the host can either walk the file system to locate another remote, which in this case of the demo, that's what I do is I /up and I go into web2 server build container for a server build. And that's how I'm pulling off the code. You can access remotes on different servers in various ways. If you're in Kubernetes, you can use a shared volume. If you're on AWS Lambda, you could use S3 streaming, or you could also just use normal fetch with a custom plugin that I've written. For localhost, streaming can be really useful if you're looking to pull in code from other deployed applications out there on the web. If you don't want to have to run everything locally, your team could just federate code through fetch or through streams or any other thing like that just to get the code in the system. If you're not really worried about the server-side aspect, then for client-side, all you'd have to do is point the remote entry file to the production URL, and you could just use production to run everything, except for the local build that you're actually working on. So I also have a quick example of actually doing server-side rendering. So if I hop over here and into my server-side rendering, I've got website 1 and website 2. They're both, have a client build and server build just like you would generally have. And what I will start out with is just checking out my build and making sure that I have everything configured. And I believe I already do. So there's module federation plugin. And I'm just using the standard React shared solution. And you'll see here my container.js. And if I look in the client base, I've also got module federation plugin, same kind of setup, but I don't need to specify the path of the remote because it will just be globally available in browsers. So let's go ahead and run this one. So what I'll do over here is I'm going to yarn start it. Make sure that I've shut this down. And then once this build is ready, I will showcase a very basic example. So in this example, what I'm actually doing is inside of my, let's see, is it index? Nope. Inside of my app, I have a import to website2 / some component, and then I'm rendering it out. So one of the cool things here is if you're doing server builds or something like that, you can use a normal require or a normal import. You don't have to use the async promise. So you don't really have to worry about suspense issues as much. The one kind of drawback or thing you need to bear in mind is if you use a solution that's using synchronous imports, there has to be a dynamic import somewhere in the hierarchy that leads to this file. So because this is app that I'm doing it in, I'm just using a dynamic import at the root. That's import bootstrap. And then inside of here, I just have my normal React element. And what that allows you to do is pretty much hoist this some component from website 2 up to the nearest promise and make sure that it's available prior to executing the code. So if we go over here and load 3001, you'll see I've got, this is website 1. And this is a very basic example, but if we look at it, yeah, I've got some component, which is actually header, and this header is being server-side rendered. So if I go and inspect it, or if I go and view the source on it, actually, why can't I view the source? There we go. So if I go and view the source here, you're going to see that header is actually rendered, and header comes from a different website or a different, remote. So if I now go to 3002, we're going to run the standalone application of what I'm federating in, and it's super basic because I didn't put a lot of time into it. So it's literally just the header server-side rendered. So that gives you a really basic example of how you can apply this to server-side rendering and how I'm able to import code from a different Webpack bundle on the fly and just render it out. So that is a very simple example of SSR. I'm going to jump back in here. And this works really great in like a Kubernetes or localhost environment, but how would you actually handle this in a Lambda environment? It's slightly more complex to do, but there's two solutions. You can either use streamed federation, where you at runtime pull code in from S3, or you can use re-artifacting, which is a more CI-heavy approach. But the idea is when you deploy up your individual Lambda services and all of that, you also have the other services that depend on federated code take the deployed bundle from their S3 bucket and pretty much artifact it into the Lambdas that they currently have. So it kind of gives you that ability to have on-disk access. But the cool thing with doing a re-artifact is you don't have to rerun an entire build. You pretty much are just zipping up some files that are already built and done, and you're just telling the Lambdas that, hey, you should start serving from this zip file instead of serving from whichever one you currently have. So it's pretty seamless, and it's not a ton of work to actually make that happen, and it's pretty quick to actually do as well. So supporting multiple package versions when shared contains breaking changes or something like that. This is a more in-depth example of how this actually would work. The first thing I do is I exclude some things that I just don't want to include. And then I ignore versions on React and React DOM because I can't have multiple versions anyway. And you'll see on this other screenshot over here, this is what it actually looks like. So I pretty much just go and reduce down the package/package JSON, pull the version off, and then you'll see I have an ignored version, for example. If it includes the current package being iterated, then I just pass the name and the package name. Otherwise, in the case of like Lodash or something, I can pass it the package name with a key being the Lodash version, and then just the package that it resolves to. So that's how hosts are able to override remotes, and remotes are able to pull in their own dependencies if they see that they use Lodash 4.1 or something like that. It won't match, and the remote will download its own copy. So I'm going to show you a more sophisticated example, which would be using an entire like application stack where we're sharing context, routing, and the app shell. In this example, I've got, I think, 5 independent repos running. Yeah, so in this shared routing example, I will have 5 independently deployed applications. And if I look at the Webpack config, I get module federation in there. And then I pull down, this one's the dashboard. And I pretty much specify some basics. And then I say what I'm going to expose. So I'm going to expose the dashboard service. And these are the other remotes that I'm going to end up consuming. And then here's just some basic things that I'm going to share. And this is more or less the same throughout all of these systems. So if I look at, say, dashboard, for example, I can look at the app, and what you'll see over here is I'm using suspense, and I want each of these 5 repos to run as a monolith. So I want them to look exactly the same no matter which port you're on. The browsing should be the same. The nav should be the same. The app should look identical on any port in any system. And to do that, what I'll actually do is federate the shell back into the remotes. So the shell is typically, port 3001, but all the other ports are federating their own shell. And because of how Webpack works and how module federation works, I can have things like circular imports happen, and the circular imports won't impact the way it works because Webpack will already know that it has whatever it wants in its own build already. So it won't attempt to reach out through the global scope and re-import itself. It knows what it has, and it just resolves it as usual. So let's start this one, because this one's pretty cool. And we'll start off on port 3001. And I'm going to demonstrate a couple different things in here. Firstly, there's no page refreshes like you'd usually have in a micro front end. And one of the other cool things is I actually import various side effects as well. So let's see if it's running. Cool. So this is the dashboard service, and you'll see that I'm pulling in some various pieces of code here. And let's say I go to a different page. You'll see 8.8 kilobytes downloaded. And this is a completely separate app. This thing can be deployed on its own. I believe it sits on port 3002. And it's its own standalone app. And I'll go through all the ports to just show that off. And then I have this, which is a really neat example because I just pulled this off the internet and found another thing that used Material UI, copy and pasted that repo in here, and everything just worked. And the only payload that I had was I used some SVG things, and then I have the profile page, which is 100 kilobytes. It's a little bit heavier because I believe there's like some form stuff in here and whatnot. But you'll see that I'm pulling in this image, and this image is from port 3004. So Webpack's able to federate any side effect that you have. So now let's try going to dashboard on port 3002. And what you'll notice is the same application loads up, different micro front end, but it works exactly the same. The routing is exactly the same. If I go to, say, port 3004, you'll have the same experience. It works, and I can browse back through. And each route is its own front end, or its own independently deployed, standalone running service. And if I go to just port 3000, we should see, oh, I don't think I actually have a port 3000. I have a small bug in that one. So anyway, but you get the idea. I can go to any port anywhere and it all works. It all feels and looks the same. It behaves as if it's a monolith. And if I browse through the entire flow, for example, if I go to, say, 3001 and then I go to profile, I think the whole end-to-end flow is about 100 kilobytes. So I'm browsing through multiple applications, and I only really pull in 100 kilobytes of extra code. So in this case, I'm going to actually measure what I've got. So here's 8 kilobytes for the whole orders micro front end. And then the dashboard, which is heavier, is, you know, besides the React charts, and none of this is optimized because I'm in dev mode, so it's obviously larger. But if we excluded React charts, you'd be looking at about 100 kilobytes. With it optimized, you're also looking at it being pretty small. But yeah, for me to go through 3-4 apps, because the app shell itself comes from a different origin as well. So to pull in everything here from various different ports, 3000, 3000, 3002, 3003, 3003, 3001, and 3002 again. So for me to pull all of that in, I'm really looking at, if we exclude the charting system, I'm looking at, you know, 20 kilobytes, 60 kilobytes, 70 kilobytes, roughly. So that's really tiny considering that I'm pulling 5 different apps together, all standalone, all deployable on their own. And so, yeah, that's one of the cooler demos that I have on this. So let's see what else I've got for you. So this kind of model of the app shell, the idea that we had was the app shell contained the routing system on its own. And that might not work really well in most cases. You might want to control your own routes. So that's pretty easy to do. In this scenario, what I end up doing is I take the local routes that I import from this folder, and then I'll take the app1/routes from a remote source, and I will stitch them both together. And then I use the React router and switch statement here, and I'm pretty much binding all the remote routes together with the local routes. So each team could control their own routing locally, but the pattern still applies when you go to a different app. Just like in the dashboard service example with the 5 repos, you could do the same thing here where you just concatenate all the routes together, and then each team can add their own stuff to local routes, but they'll have all the routes accessible from any other remote build. So one of the really cool use cases for module federation is A/B testing, but controlled by Adobe Target or Optimizely or Google Optimize, any service that you want. So you're able to integrate marketing and analytics seamlessly into React code, and you're not actually pasting stuff into, say, Adobe Target's little text box, but you're federating code from another repo that's deployed using Adobe Target to actually pull in and orchestrate the code from that other repo. So Target really contains almost nothing. It contains like 4 lines of JSON that says, hey, this is what I want module federation to do. So it orchestrates module federation. So here's a little example. It's really perfect for A/B testing, tag management, analytics. Products like, Google Optimize or whatever lets you federate stuff at runtime. Separate teams are able to deploy a user experience without impacting product delivery. A/B tests do not enter the main code base, and A/B teams are able to write real React code without having to impact a different repo. So what you'll kind of see in this example here is I pretty much went into Adobe, I got a preview link for something, and then it loaded up the prop inspector and a couple other dependencies that it need, along with the actual remote that I want. And, this is all coming from separate Webpack bundles, but you'll notice that I was able to inject, into an environment that I didn't deploy, I was able to inject a prop inspector to see what's happening and debug it, and I was actually able to inject different components. So in this scenario, I'm going to now swap it out, open up a new tab, and I'm going to try injecting something different. And so in this case, I'm just injecting props into the current host or the current other system without deploying anything. So instead of having to do your usual A/B testing or anything like that, what you're able to actually end up doing is just feed props into it or feed entirely different components into it. So you can really control anything that you've got. You can also do things with say, just HTML and have it inject HTML. So it's really versatile, and it offers teams a whole lot of benefits. So I'm going to jump out of that, and we'll just go on to our next slide here. So streaming federated modules. So this is a really cool example, and this pretty much uses S3 to actually stream code in real time over the wire into any bundle or build or service that you're currently using. So I would say this is also probably one of the simplest approaches to doing things like this. So what I'm going to do is just make sure everything else is shut down, which it is. And I'm going to boot up S3. And then I'm going to go to my streaming example, and I'm going to build everything, deploy everything to S3, and then start a service up. And this one's going to be pretty much, I'm going to federate middleware from one app into another one. So if I look here, I've got app. If I go and look at my server, I have, a really basic example. I've got federated, and it's going to use this extra root middleware. And the middleware is coming from a S3 bucket, and I'm pulling it in like that. And if I go and look at the middleware, it's super, super simple, but the concept is very much the same. I import express, app use, and then I'm just going to send back some response. So now if I go here and go into 3001, there we are. So now you'll see I've got a server-side rendered page with the typical app stuff that you've got. And now I'm actually going to go to a different route that's not part of this single page app, but it's a different route inside of Express. And when I click on that, you'll see the page kind of reloaded, and I pulled in from port 3000, I pulled in federated middleware and rendered it back out to the end user. So that's a really neat example of just like what you can do. I know it's kind of basic, but it's a pretty cool example that you can have a single page app, and you can actually have separate middleware that comes from separate repos. So I'm going to shut this down again. Sorry, I'm going really quickly here. I know I have a lot of content, so I'm just trying to get through it. So sharing state's also possible. Like you saw in my big app shell demo, sharing state was happening there, like React context and routing and stuff like that. You can do it with Redux stores, objects, really anything that you want. But there is one consideration that you should make. If you're messing with data or sharing data, you should treat it almost like an API. So the remote should expose a normalized state module that prevents changes in a remote impacting the stability of the host. Because if you change your Redux store or something like that, the host is still consuming data through whatever mechanism that it had. So the idea with shared state APIs would be they have data contracts, the same way that you would do it with a current API that uses a get or post method, or even backend APIs or anything. You create a contract so that when a team refactors something, it's still normalized and sent back to whoever wants to consume it. So another really neat thing that I've brought up is a Webpack 4 shim. So this is all running in Webpack 5. So doing stuff in Webpack 4, like I use it in Next.js, and Next.js doesn't fully support Webpack 5 just yet, but I created a shim so that I could use remotes on Webpack 4 bundles. So like A/B test, for example, that's a very good case where I have Next.js, but I also need to have some kind of remote code coming in, and I want to be able to override it or certain things like that. So this is a pretty ugly example, but this shows the shim being made available. So what I do is I add some overrides. So this is how I actually use shared, or how stuff is shared. So I'm doing really basic ones like React, React DOM, next link. And then I have this import all, which is pretty much a context loader. So I can loop over and actually create things that a A/B test could consume from the host. So creating this bidirectional host feel. So the key that I ended up doing was I just have inside of my module exports, I pretty much recreate some rudimentary Webpack 5 runtime setup. so that I can actually feed all the data back in, and there's an API the same. So this is how it would look to consume it on a federated module, or this is how it would look to consume it inside of Webpack 4. In this case, I'm using A/B tests. So window A/B test get returns a factory. I execute the factory, and I get the default off of it. And then I'm able to dynamic import and load stuff from a remote source into, a legacy system or something that's not built with Webpack. If you weren't doing it with like Next or Dynamic or React, the other way that you could do it instead of just other bundles is, or other, like something built in Rollup or whatever you've got, you could just use window A/B test get something, and then you would just return this. And you could make this async await, and what it'll end up returning is a module the same way as if you had imported it. Okay, so some of the next steps that I'm looking to take on with module federation is I want the ability to create a dashboard. So this is currently in progress. And the idea is now that you have all this dynamic stuff happening, you want to be able to orchestrate and visualize it, kind of like how you'd have an AWS console or a PM2 console or something like that. So what we're going after is visualizing who uses what, the ability to control code freezes during deployments. And the idea is that you could code freeze specific remotes so that you could still deploy to production other remotes that don't impact the critical business flow. So you're not doing a full lockdown on something, but you're just locking down the critical flow, giving you a lot more flexibility. We're also going to have versioning as well, so you can actually roll back certain versions or deploy updates to specific federated systems. One of the cool things that this also will add is the ability to hot reload production. So a Lambda or another server wouldn't have to actually reboot itself to receive these changes, but we can hot reload them while they're still running. I want to improve some tooling for unit tests. It's possible right now, but it'd be nice to have a couple helper functions. I'm looking at something like IPFS and federation, which would let you have distributed CDN style things where you have peer-to-peer loading. So in the event that your remote goes down or is offline, you could fall back to either another CDN or you could fall back to IPFS, which is guaranteed to always have it somewhere. I'm looking at scope isolation, so the ability to use globals inside remotes without polluting the host. And I'm looking at doing this through sandboxing with either VM, the Realms polyfill, or just proxies that help set it up. And yeah, so somebody who's using this, they were trying to create a dashboard-like system similar to Grafana, where you could add different apps or modules, and they didn't have to kind of be redeployed whenever someone adds it, but the user could select from like a marketplace that they want this, 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 and this, and it would just come together at runtime. And when he previously built this, it would take a month, and he was able to build it in 3 days with module federation. So it definitely speeds things up a lot in terms of development. And yeah, so thank you for having me here. And if you do want to find out more, you can go to GitHub/module federation. That's where all the official stuff that is happening exists. I also have a little Next site up. It's not really fully finished, but it tries to bring in all the videos I put on YouTube, all the articles that have been written, and various examples and stuff like that. And then on Twitter, feel free to reach out to me at Scripted Alchemy, and I'm happy to discuss any of these things in more detail. So yeah.
Thank you, Zack. Thank you for your presentation.
Sure.
I personally have a love and hate relationship with Webpack, so I'm not the best person to ask questions to you, but I could see a lot of them on the chat. So if you could please take your time to get yourself familiar with it. I think the first question was from Mohammed. And in the meantime, as you read those questions, Juho, Marco, if you are still here with us, you could join us now for the final discussion panel.
Okay.
Start with those questions.
Yeah. Let's see. What are the possible library types you can pass? Yeah, so you can pass literally anything that Webpack works with today. AMD, UMD, System.js, CommonJS, CommonJS module. Whatever Webpack can do, you can pass. So this is full-on Webpack compatibility with anything that you want. Anything Webpack does today, any file, any binary, anything that it can read today will work with module federation. Let's see what else.
The next one is from the Vangelis tree copies. I think the automatic vendor federation plugin is fire.
Yeah, so it's really cool. It solves a lot of issues with versioning and just having to manually manage it. One of the things that I would say is it needs to be refined. Right now I'm using dev dependencies and dependencies, but you could perhaps add something like a package JSON or peer dependency or something like that, and have it read from there so that you kind of can declare what's being shared from inside your package JSON, or just have it look at dependencies only. And I'm able to share things like express between instances, pretty much anything. And yeah, it takes care of versioning. So the other question here, does shared work with nested paths? Shared right now, we don't allow it to walk nested paths, but you can create a loop. So if, say, something like Lodash, if you want to do the nested paths, what you could do is just walk over Lodash and pretty much go into their ESM section or whatever it is, and then just loop over the files that are in there to make a separate chunk from each Lodash import. So yeah, that's also possible to do. It's just not supported out the box. Maybe I'll write a plugin that can help with that. And yeah, let's see if there's any. Yeah, so testing across apps must be interesting. I wonder if it just works out the box. So yeah,
I think. Could you please connect again?
Sorry about that. Yeah, so testing across apps is definitely a little bit more interesting. How we do it in, say, like a Lambda environment is if we do re-artifacting, we have the code from the other bundles. So what we can do is extract their unit tests and run them all from like one bucket. Otherwise, other interesting ways is you could just federate the unit tests in, or you could stream the unit tests on demand if you have the S3 streaming or the streaming plugin. But yeah, like with unit tests, I would like more tooling around it to make it easier, but it's totally possible. Anything that goes through Webpack, you can have it run. End-to-end tests are also possible, but it really comes down to the implementation detail of what you're trying to get. Do you think federated component libraries could be a thing in the future? Or do you think it's mainly across micro-frontends? So yeah, this is totally not limited to micro-frontends. It's just the best example that I can think of where the most pain comes from. But you could, like right now, I am looking at applying it to pattern libraries, and I'm looking at applying it to the app shell itself, and looking at applying it to like middleware, authentication, all sorts of stuff like that. So I know I mostly showed off UI stuff here, but I did try to go over like, here's pulling in just middleware. Or if you want libraries, totally works with libraries as well. So there's really no limits on what you can do. If you just want a library of modules or utilities, then it's no problem. It'll work with absolutely anything. Oh, more questions. Next.js, when will it arrive officially? Next already merged in my Webpack 5 PR to them. The main issues we're facing right now is they need to still update their loaders to work with the new format, and they need to address some hot module issues. I do have on the module federation repo, I do have a running version of Next.js powered by Webpack 5. It works perfectly in production mode, but the development mode mostly works pretty well. But there's the potential that there might be the occasional bug. I've just not tested it thoroughly. But I do have things deployed using my module federation /next and or Webpack 5 /next. The big thing that I need to write some docs on is how to actually get around the single runtime chunk that Next has. But it's totally possible to use one single runtime chunk and still have module federation work. Let's see. When do you think Webpack 5 will be officially released? I can't specifically say because this is open source, but I would say we're looking at mid-year release. So that's the best that I can give an answer to that. But Tobias would be the one who would know the actual release date. This is open source, so it's a little different. So is it possible to use different frameworks? Yeah, like if Webpack runs, it'll work. The question is can the framework integrate with something like React? Or if you're doing cross frameworks, something like single SPA could be really useful. So you could use single SPA to handle your mount points with some kind of standardized pattern, but you would still be able to share all the vendor code and any modules or utilities in between them. So again, that comes down to what you're looking for or what you're looking to kind of bind together and how. But if Webpack can bundle it, it will work. Can federated middleware access a file on a host? Yes, it can. So it pretty much runs like a monolith. So the idea with the federation is you would not notice any difference between a bundled monolith and a federated system. So it's the host that runs that middleware as if it were a module that the host imported itself. So it can do anything that you want. We can also sandbox it so that it can't do anything that you want. But yeah, you can read from the file system, all that stuff. Let's see, shared vendor dependencies. I'm using state store management, which is extending Redux. When adding this vendor to shared array, would it be possible to add dependencies easy peasy as well? Yeah, so when you add the when you add whatever you add, what it's going to do is just like when you do. Oh, I missed a question. Okay, I'll come to you. If you add easy peasy or whatever you're trying to add, it kind of works like how code splitting would work. So if that library depends on its own dependencies, it will automatically package them together. Regardless of if you import it or dynamic import it inside of its own app, it will be an additional chunk. So whatever it needs is supplied. It's not just the file, but it's everything the file needs to run. Like in my case, I'm doing like Apollo, but Apollo has lots of dependencies, but it still works. So yeah, dependencies are a problem. Just like as if you bundle it in Webpack, it'd be available. Same thing. And you could also do nested remotes. So you could have a remote that imports a remote that imports a remote. That could import a part of the host running inside of the host. So circular and nested imports works just fine. Okay, so back to the question I missed. Expose a way to set public path and remote entry. So the thing with that, we're looking at maybe a slightly different direction. So instead of just having the public path exposed, you could work around it with having exposed or something. I'm also looking at just cobbling together a little plugin that adds the capability to the Webpack runtime. But the official way that we're looking at doing this is adding pretty much an initialization stage. So right now, module federation, the remote runtime that you attach, bootstraps the exposed and override API. That's how they're able to communicate across different systems. So what we're looking at doing is adding an initialization step. So when the remote entry boots itself up inside of a host, it will actually run the API that exposes everything. But prior to that, it will also run the initialization file, which would let you, expose the public path or change the public path at runtime. So that will give you a lot more flexibility because you'd be able to access the entire internal runtime, and you could make modifications as needed versus a one-off solution. But in general, we're not trying to add hooks to the plugin itself just because of the complexity and the potential for stability issues.
Could you give the bit more missed question?
Oh, damn. Okay.
It is a question for 4 minutes ago. Could you go over that bit with synchronous dynamic imports again?
Yeah. So synchronous imports. Let me get the code up here. Am I still sharing them? Let me get the code up here because it's going to make it a little bit easier to demonstrate. So in the case of, say, server-side rendering, what I've got is like we saw inside of app, I import website 2 from component. So website 2 is still a remote, but the trick here is if I were to move this down somewhere else, what needs to happen is in the path to get to this file, there needs to be a promise somewhere so that it can work synchronous, because when you code split, or like if you code split like I don't know, like homepage, and homepage had a synchronous import like this, what would happen is the dynamic import of homepage, it would hoist any of these dependencies up into the nearest promise that it can locate. So when you're downloading homepage, you're also attaching and downloading website to some component as well. In my case, I use the bootstrap file. So pretty much just at the entry point of my app, for simplicity reasons, I always have a dynamic import to hoist to. And then the bootstrap is actually where the thing boots itself up. So this async promise is being resolved on this import. So it finds the nearest import in its chain of imports and will hoist any additional requirements up into that. So that you have to have a dynamic import somewhere in the chain if you're using synchronous imports, because Webpack needs a spot where it can hold up the execution while it resolves any additional chunks that it might need. And let me jump back over here. Let's see if I miss any else. A few seconds ago. Okay. Can federated middleware from app2 access a file in the host config? I think I just answered that. But yes, it can. It can access anything. It's as if you just had the file sitting in the host already. Shared vendor dependency statement. Okay, yeah, I've already gone over those. A little off topic. Do you know what the status of the next version is for Redux First Router? I've kind of fallen out of touch with those repos just because I've been focused on this for the past 8 months. But I believe Respond, I have a private repo where Respond is already functional. It's pretty sophisticated, and it would be really cool to integrate federation with those type of systems. I'll try to get around to it once I have everything sorted out in module federation. We're just cranking a lot of features out and a lot of extensions and plugins for it right now. But I will try to go back and backport it to like React Universal and things like that. And even with loadable components, you're able to pull in the async chunks from a remote so that when you server-side render, you have all the usual components that, or usual files that you would have. So there's no waterfall effect, keeping your RTT to like one trip. Cool. So I don't see any more questions flowing in. Let me make sure to scroll down. Okay.
There's one new from Mikołaj.
Yeah. Feature looks incredibly powerful, but I wonder how useful it would be for a simple use case. Specifically, we have two close related single page apps in a single monorepo. Yeah, so, you know, if you can, it depends. Like I'm looking at this for scale where I have 20 to 50 repos and I need to orchestrate hundreds of modules across them. And each you know, build is like, and also like with a monorepo, I have to wait like 15 minutes for tests to run. And you're still bottlenecked by that single master branch. So I want to be able to deploy anything at any time, anywhere, and it should just work. It shouldn't need any coordination. I shouldn't have to wait for other things to build. I shouldn't have to argue about who's going to master first, stuff like that. But if you have something really simple in a monorepo or whatever, and you have some duplication, you could still apply it there and just say use the shared aspect to make sure that things are shared correctly. But if you're doing a whole monorepo build and deploy, then you're kind of bundling everything together. It's just, it's not very convenient when I need things to run standalone and I don't want to be bottlenecked by a single deployment pipeline. So hopefully that answers the question. Yeah, cool. So yeah, we probably are running out of time. We're over time. So you reach out to me at Scripted Alchemy if there's anything else that you need or want to know.
All right. Thank you, Zach. Thank you for your presentation.